Alrighty then, corn children, children of the corn. It is a fine day for mathematics. And today we're going to be looking at the quotient rule. Division is the operation inside the derivative. So we're taking the derivative of a quotient. We would assume the natural domain, meaning g of x, should not equal 0. Just put that out there. All right, here's your little formula. Yeah. Let's take a look. Here's how we're going to remember it. We're going to say this over and over and over again until we get it. Ready? Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Again, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Whew! Now let's be clear, this is a minus sign, and so the order of the numerator makes a difference. That minus sign has lost points for thousands of students. We're going to be careful with that. All right, let's do an example, shall we? Okay, good idea. Here we go. Find the derivative for y equals 3x plus 7 over 5 minus x. I want you to be crystal clear about this denominator. That x has a scalar of -1. Just be careful, all right? Be careful. So let's start this, shall we? Here we go. I'm taking the derivative of an equation. I take the derivative of both sides. This is not y equals. This is the derivative of y equals. Big, giant fraction line. Here we go. Denominator times the derivative of the numerator. All right. The derivative of 3x is just 3. The derivative of a constant is 0. So this is 3 plus 0, 3. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. We look in the denominator. The derivative of the constant 5 is 0. The derivative of -1x is -1. All over the denominator squared. Yeah. All right, let's simplify this down. It is not a requirement on the AP test that you do simplification, but it's often really helpful so that we can use it. First of all, I want you to notice, no, you cannot cancel those. There's a giant minus here. That is not a factor. Stop it. Just stop it. Instead, I'm going to distribute the 3 in the top, on the top half. So this is 15 minus 3x. Distribute. Now look back here, look back here. We have a minus and a -1 factor. Yes, those will cancel. So this is now plus 3x plus 7. All over the denominator squared. I just leave it. I don't do anything with the denominator. I leave it in its factored form. Oh, look at that. Now this is just a coincidence. This does not always happen. But the -3x and the positive 3x cancel. Oh, that's so cute. And now my final answer would be 22 over 5 minus x quantity squared. That is my derivative. And so now if I wanted to find like the slope of the tangent line to this function, I could evaluate it at a value. So if we wanted to find the slope of the tangent line to the original function at, for example, x equals 1. Well, let's remember this weird notation. It's dy dx, the vertical line meaning at x equals 1, and all I have to do is fill 1 into this. So it's 22 over 5 minus 1, quantity squared. So that's 22 over 16. You can reduce it if you want. And that would be the slope of our tangent line. We could write the equation of the tangent line. We could do all of that stuff. All right, so that is our quotient rule. Let's tackle a larger problem. Same quotient rule, but a larger problem. Here we go. Let's look at this one. It just looks scary, doesn't it? Here's what I need you to notice. It is overall a quotient, but within our quotient, there is a product in the numerator. So we're going to be super careful when we go to do this. Here we go. F prime, that's the derivative of the left side of the equation. Here we go. Now we're going to do this slowly and thoughtfully. Denominator. Well, the next thing is derivative of the numerator. Watch what I'm going to do. I'm not going to actually do the derivative yet because it looks complicated. I'm going to write that I intend to do the derivative of the numerator. So there's the numerator, and I'll come back to that part. Denominator, derivative of the numerator, minus the numerator. And I think I could do the derivative of the denominator right away. The derivative of 2x is 2. The derivative of negative 1 is 0, so plus 0, so it's just a 2. All over the denominator squared. No, those don't cancel. Cut it out. There's still a minus there. All right, so we're going to come back to this part right here. Well, what is this part? Well, this, ladies and gentlemen, is a teeny tiny little product rule. Now, is the product rule derivative multiply? No, that would be poop. The product rule is first times the derivative of the second plus the second times the derivative of the first. So we're going to replace this with all of that. What? I know. Here we go. Equal sign, giant fraction, denominator. All right, 2x minus 1. There it is. Here we go. Big parenthesis. Product rule. First times the derivative of the second. The derivative of sine is cosine. Plus the second times the derivative of the first. The derivative of x squared is a power rule. The 2 comes down, the exponent drops to 1 is a 2x. And look where I'm going to put it, right there. So this is our product rule. Back here, just for the sake of convenience, I'm going to slip the coefficient of 2 in front. And that's what we've got. Now, if we wanted to, and I'm not sure I really want to, I could FOIL this out. This is a binomial. There's a plus sign. This is a binomial. You could FOIL that out. We're going to have one like term, but I'm not sure how productive that's going to be. I'll do it, but I'm not in love with the idea of it. No, those still don't cancel. See, the minus cut it out. If you FOIL this out, you've got your firsts. That's 2x cubed cosine of x. You've got your outers. That's 4x squared sine x. You've got your inners, that's negative x squared cosine x. And you've got your lasts, which would be negative 2x sine x. See what I mean? That's like crazy. And then we still bring this one down. Now, all of that, and these are the only like terms. They have x squared and a sine. You could combine these. 4 of those hideous things minus 2 of those hideous things would make 2 of those hideous things. So I'm way too lazy to do all that work. So I'm just going to scribble that one out. And this is now a 2. And that's it. It may be ugly, but it's correct. If you really wanted to, you can factor an x out of the numerator, but that's it. Yeah, I know. Well, I hope you enjoyed that. That was an example of a quotient rule with a product rule in it.